Good morning, participants. I'd like to introduce today's session in charge, Mr. Manimaran. Mr. Manimaran graduated as Electronics and Communication Engineer from Anna University, Chennai. Currently, he is designated as an Assistant Manager in VI Solutions, Bangalore, and handling the major responsibilities of supporting various industries in implementing several turnkey systems and system integrated projects using NI products. He is also handling the major responsibilities of improving the quality of engineering and science education and eradicating the improvised method of education and inculcate the interest of lab. Manimaran has traveled far and wide throughout India and Sri Lanka, has delivered through provoking lectures which inspire the students and kindle their interest towards labbing, and also interested. I visited more than 200 Indian engineering institutes. He had conducted more number of hands-on training to engineering students of various branches on LabVIEW basics and data acquisition. He also had conducted many faculty development workshops on various trending technologies, including RF communication and wireless systems, advanced signal processing and data acquisition and control, etc. He has delivered more than 350 lectures on experimental engineering education on varied technology topics. His interest areas are RF communication and wireless system, measurement and automation, sensor, data acquisition and signal conditioning, wireless sensor networks, FPGA-based embedded system design. So this is the brief introduction of our key speaker today. Sir, I welcome you to this session, sir.
Thank you, sir. Thanks for the introduction.
Yes, sir. Yes, sir. You can start the session, sir. Over to you.
Thank you very much. Very good morning to all. Let me share my screen. Could any of a participant or the organizer, could you please confirm me that whether my screen is visible to you all?
Sir, it's visible, sir. It's visible.
Yeah, great. Thanks. So first, I would like to start with NI-LVS sessions. So very basically, what is NI-LVS, how it could be used for our lab activities, how we could use with it, probably we can discuss. I'll just share a small intro as well as agenda for today's session. Today's session is completely on NI-LVS modules. So probably morning session we'll be discussing how LVS can be used for regular academic sessions and how LVS could be helpful for current situations during this pandemic, how we could continue our engineering labs in the remote form, how we could use with it. So those details we'll be seeing it. And afternoon part we'll see the demonstrations, how we can connect a module, how we could program them. So those parts we'll be seeing in the afternoon session. So this is what the for the whole session for today, pre-lunch as well as post-lunch sessions would be. So I hope it is clear to you all. So before I start with, I would like to show you how LVS modules are and what are the elements are available in this LVS modules. So this is the little one version low. It's an older version of LVS, but many colleges in India they have this module for their lab activities. So if you see over there, this is something as a one instrument which has all your lab hardwares in it. So for example, that's why if you see over there, they mentioned as a NI Educational Laboratory Virtual Instrumentation Suite, which is your LVS. So here, if you see in this particular hardware is one enough for the entire lab elements. So instead of we have multiple hardwares as a function generator, oscilloscope, and we have a body analyzer, we have a current analyzer or a variable power supply. Instead of doing these many items, having in a single workplace, so which would be occupying more of your space, we have a modules called as NI so where we have all these items are available in this. For example, if you see here, this module has a function generator in it. This module has an oscilloscope in it. This has a digital multimeter in it, and this has a impedance analyzer in it. This has a power supplies in it, variable power supply elements. You have a fixed power supplies as plus 15, minus 15 volts over there. And if you see in it, you have these knobs for controlling the function generator and variable power supplies. This is something as a top board on top of the Elvis, which has been mounted. Do you see that this blue color board with we have breadboards connected with this? Apart from these inbuilt instruments, so we have an analog in, analog out, digital in, digital out items also we have in it, so that this will help us how we can use it for our regular lab options, so that we can have any of our circuits used for our sorry. So we can deploy any of our circuits on the breadboards, and we can make use of this normal pins what we have in it. These are normal analog in, we have analog out, we have functional programmable functional interfaces. These PFIs are these program functional IOs are used for the trigger pulses where we can generate it. We have two counter modules in it, so we can use it for counter purposes. Any servo motors or any relays need to be controlled either with digital lines or counter lines. Probably you can use with them. So these modules you can have it. So if you see with this particular module, you have an oscilloscope of 100 mega samples per second. Every individual channel you can have it, and function generator you can go up to 5 megahertz, a decent function generator range where you can work with for the basic uh, digital labs or LIC labs where you can start with. And you have a multimeter here where you can go up to 60 volt of DC and 20 volt of AC you can measure, and current rates up to of AC or DC you can measure up to 2 amps. So where it is we have a few safety in it. So this is something as an old module, so where it is only used with a USB based. So if you see here, this module will not work without a computer. So you need to have a PC or a laptop to get interface with it. Whereas if you see there, we have another hardware. This is the latest hardware, NI-Elvis-3. The advantage over Elvis-2 and Elvis-3 is, do you see over here we have only one function generator unit and two oscilloscope units, whereas in Elvis-3 we have two function generator unit and we have four oscilloscope units we have. So this is really a good one where we can go for multiple number of channels where you can work with this. And here you have this function generator and DMM in it. Along with it has a 16-bit logic analyzer we have in it. So here you have a more space to work up with your elements. The previous module we have only 3 breadboards. Here we have 4 items. So you have onboard potentiometers, onboard audio analyzers you have, And do you see over there I have a Wi-Fi element. So this module you can use with Wi-Fi, USB, C port connection, and you have an Ethernet connection. So once you have an Ethernet or once you have a Wi-Fi, you can connect it as an your network and you can communicate with it. So if you provide internet access to it, then this module can act as an IoT device as well. So this is one good option where you can really get started and you can use with it. So this module has a USB port also in it for storing your data wherever you conduct your experiment. So you want to store your element, so you have an onboard memory. Along with you can have a USB host also. So you can connect your external hard disk or a pen drive where you can store your data. And this module is one good thing is higher than your Elvis 2S. This system will not work without a computer, whereas this NI Elvis 3 hardware can work as a standalone computer because this has a inbuilt real-time controller and processor in it. This is a latest state-of-art SoC module. So SOM module also involved in it. So we used to call it as a system on module, which means this is an entire system on a module where we have analog in, analog out, where we have digital in, digital outs, and counter lines, and custom IOs also there, which acts as a single system. Once you program and dump in it, it will act as a separate system over there. And wherever you want to control, you can easily control through your Wi-Fi or your internet modules where you can work with it. You can assign a separate dedicated IP address over it and you can work with it. And you can easily do with this hardware. So I'll just show you a few product details in it. So do you see over there this particular module? So where we have a 4-channel of oscilloscope, each module where you can go up to 100 megasamples per second. Individual channel you can go up to 400 megasamples per second. This is really a high one in the normal system. If you take a dedicated digital storage oscilloscope, you'll be having only one particular operation or one particular purpose, where it will only acquire your data and show your different math functions and store your data there. Whereas this is a combination of several instruments in it. So we have a different instruments we can use with this. It can act as a logical analyzer, it can act as a function generator, it can act as a pattern generator. It can act as a UART or a SPI or I2C protocol based devices also. We can control with this. And since it has an Ethernet port or a USB port, if you want to connect any cameras to it, anything as a Ethernet based camera or USB based camera, you can connect to it and you can work on it for standalone applications or any high speed related applications, because it has an FPGA in it. Whereas if you see that we cannot compare this module with a normal DSO module, and we cannot use with that, because the functionality wise these models are really high, where we have a lot of options. And moreover, these modules are programmable also, so you can program these modules remotely and you can work with it. So here I'll show you a simple comparison about how exactly the modules what I have shown here. Elvis 2 module with an Elvis 3 here. Do you see over there the version and the resolution of a module, number of channels, and the sampling rates are really high. So these models can go only up to 5 megahertz, whereas if you see that the latest model we have up to 15 megahertz over there, and the sampling rates also really high. The bandwidth these modules also really high we have. So 100 megasamples per second we have as a sampling, and the resolution is a 14-bit resolution. This is a really good one. And if you see over there, the power supply ranges also we have high. These modules can go up to 15 volts plus or minus range where you can work. The older modules can go as a variable power supply of only of 12 volt plus or minus. And here the analog in analog out also will be more helpful, because if you see, when we want to take some data from a strain sensor or a pressure sensor, or anything as a accelerometer values, if you want to acquire them through your oscilloscope, you want to have something as a lab experiments which we are doing in it. So for example, if you are designing something as a class A amplifier or a class B, class C amplifiers, so in that cases, if you see over there, you can easily build your easily you can do your circuits on your breadboard, and you can make use of the oscilloscope lines, or you can make use of the analog input lines to do your acquisition part. Preferably suggest you to go with oscilloscope ranges. The reason is we have a higher sampling rate and a higher resolution, where we'll get a really a good uh, uh, what to say, really a good number of samples we can acquire and we can work with. And if you see over there, these modules you can work on any different applications. So you can work with Windows platform or Mac platform, and also you have a web options. And these modules, you have a program options of LabVIEW, Python, or C, or Simulink. You can work with it. So you can easily do a program on any other softwares also you can use it. So do you see over there, these are the devices which is inbuilt in this module. So whereas we cannot have a separate function generator, we don't want to have a separate DSO, or we don't want to have a multimeter, these modules can really go with the multimeter modules and really use with that. So that is really a good one. And these analog input modules on the sides are really good, where we can have our custom signal generators, where we can generate of our own for our signals. For example, if you want to have something as a digital electronics lab, so where we are generating something as a patterns for 8-bit values, or you want to have something as a gray code modules, so where you want to have your conversions or your program cycles, so you want to generate things, so those logic analyzer and pattern generator also you can easily use with this module. So this helps you to go with that. So here we have several programming methods to use with it. Through LabVIEW, you can easily do it, or any other web-based modules also to do with it. So here, if you see there, so I have one module with me, so where I have this measurements live. So where I have this hardware, uh, I can go for an oscilloscope and function generator combinations. So where I can go with this. So here you could see there, I have a function generator, I have an oscilloscope. I stop function generator, so there won't be any data in there. So when I run there, so here I can choose what kind of signal I need to go with, whether sine or a square. So if I take a square, so what kind of frequency range I need to work with. So here I have a different frequency ranges where I can go with. So as I mentioned, you very millivolt ranges to the 15 megahertz where you can work with. So if I say something as a sine, if I go for a 1 kilohertz, after going with 1 kilohertz range, probably if I want to tune to different one, so I have something as a 19 kilohertz range. So here you can simply zoom on the oscilloscope part. Could you see over there what is the sampling rate in it? So you can go for even a higher sampling rate also. So 50 mega samples or even lesser than you can have it. So once after you make all these things, still you can do lot of operations over here. You see over there additional operations you have. For example, if I take some FFT parameter for it, for the channel 1, so for channel 1 alone, I want to have the FFT parameter. Do you see there in it? I come down. So here I have an FFT parameter. So this is showing the peak over there in it. So here if I want to configure my FFT, so if I want to have a configure my FFT, what kind of filter I should add with this, so I can have there. So what should be the amplitude of it? So this amplitude is very less. So probably if I can increase this signal amplitude, whether it could reflect me anywhere in it. So can we have some ranges for it? So what could be the tracking of it? So where I could measure these values there in it. So I can move my cursors to it, so that I can see the values where exactly it lies there. So do you see there is 18.749 kilohertz per minute? So such kind of operations we can really do with this. So this is something as a knob operations what you have. So what is the voltage divisions you need to have in it? So you have a shortcuts. So whether you need to increase them or you need to shrink them. So with the different unit values there with this. So here also the same way. So here, for example, I want to have a peak to peak of 4 volt peak to peak. So you can directly type with that. And here also you can have it. I need to have something as a 5 kilohertz. So it will be with 5 kilohertz there. So you have a measurements operations there. So it will tell you what is the value that I'm measuring with that. And also it will tell you about what is the FFT levels that I can take with it. So you can easily do with that. I'll run that again. So here you can easily track. So this is something where you can do everything in at a single stretch. So I'll stop it. So now what I'll do it is I'll have something as a capture it. So here I can capture this as a snapshot. So only the oscilloscope values I can capture. I can take a screenshot. So do you see over there it got downloaded for me? So I'll show in a folder. So this is the oscilloscope values there. So what are the FFT parameters that you measured for it? And what is your screen values in it? And what is the channel that you are measuring in it there? And what is the range that you have defined with your frequencies there in it? So everything we can define there. So what is the value that you can measure with the data of channel 1? So these are all with your simple informations, or for example, if you want to transfer this data to a different parameter, for example, if you see there, I can go for logging these elements. I can export it to a TDMS file, or I can save these values to a Excel file. I can easily do it. For example, I can export these values. For example, do you see there? I can export to CSV. So I'll say export data. So now show in a folder, it is a scope value, it got as a CSV file. So I'll just open with an Excel sheet. So for the traces, so what is the value over there? So this is the channel 1 data of X and Y over there. So you'll have the points of how many sample points that we have generated. It's a continuous data. So we have an enormous data with this because we have a lot of samples there. 25 mega samples we mentioned over there. So that's the reason we have a lot of samples in it. So we'll have of this much data exported to it. So this is one simple reason where we have easily avoid multiple instruments there. So do you have any queries so far? So any queries? If not, probably I can continue. Because I'm showing you something where we have a module which works as a different devices. Because for us, these are all different equipments or different devices which we need in our lab. since the single hardware which we have all these modules in it. So if one device is there, then we can easily conduct the entire lab. So now for this pandemic, when we are interested to conduct a remote lab, then this module can be connected via Wi-Fi or Ethernet, and we can share this web-based applications or a program. What we are, this is my Google browser. So in my Google browser, I have my hardware. So now here I have a simulated a device. Instead of it, if I connected with this a module. So where example, if you see there, I can get start with this. I can directly connect to this device. I can easily use with this. So when I say use control IO, in the sense I will be using the analog in analog output of the modules of the hardware of modules there. So using how to use with this, how I can control them. So we have these modules, how I can program with this. So this is the architecture of my Elvis hardware. If you see there, I have an oscilloscope function generator there. Apart from this, I have other modules also. So I have a gigabit Ethernet, Wi-Fi, I have a USB where I can interface this hardware. Apart from that, I have a separate USB device where I can connect my hardware there, hard disk or a pen drive where I can use with it. So this is an architecture of this module. So where I have a RAM in it, where I have an inbuilt memory in it, where I can dump a code and make it as a standalone. So with the help of this onboard elements, I can use. So for example, if you say analog input, so it will share you how you can connect inputs to your analog module, how this connecting your signals to your analog input. So you have a complete information to this. So where exactly you can use it for your analog input as a single-ended or differential, whether signal positive, negative, where you can connect, where you can remove, so that you can easily use with this. So this is something as a simple information to you. So from this device itself, you can easily learn a lot of parameters and you can use it. This is one single stop place where you can easily use. So you have lot of videos. So how you can use your multimeter for your purpose, how you can have a power supply for your for example, if I take something as a op amp, I need to give something as a 12-volt power supply or 14-volt power supply, so where I can use from the variable power supply. Or if I use a basic digital electronics lab, so I want to give a fixed 5-volt the power supply to the ICs. So for the logic gates, I can easily use with this, and I can easily go ahead because these things will help us. This is for the logic analyzer. Apart from the initial uh, logic gates experiments, so further we will be going with the bits level coding part in our digital labs, circuits lab. So there you can use with your logic analyzers, where for your code conversions, so where you are analyzing of your BCD values, so how exactly you will give input to it and how you can generate this pattern generators will help you in it. So these are your very important one. And here if you see that you have a teaching resources also, so this will help you out where you can use this NI Elvis hardware with different labs where you can use with this. And these teaching resources, you can use it for a different lab purposes. You can use the same hardware for a control system design, so for a mechatronics design, for a power electronics, for a mechatronics system analysis. Because if you see over there, I want to teach them about different motor controls. Then if you see over there, I have a different motors I have here. So here I have a stepper motor, I have a servo motor, I have a brushless servo motor here. So how I could use with this? Do you see there what are the modules involved in it? So we'll have there. how I can control this positions, how I can control the actuators in it. So you can easily conduct several labs with this. So for analog electronics, how you can use with this, how students can do some mini projects with this. Now for this Karnataka government, I have made conducting a mini project in the UG level, right? So when we have these things, when they have a hands-on practice, even if they are not available in college, also they can do their mini projects through the simulator related uh, devices, or through the remote lab facility structures they can use with this. This could be really helpful for the academic community in a very large way. So you have several modules uh, we have here in the teaching resources, so that I'll share you these links so that you can explore it, how exactly you can use it for different labs, how exactly you can uh, frame your lab practicals, or how exactly you can plan for your labs. So provided if you have these modules with you. So apart from this, we have a lot of options also. So where you have different lab modules also, how you can interface and you can work with. So any queries? So do you see over there? I have four instruments in my screen now. So one, I have oscilloscope, I have a function generator or arbitrary wave generator. So here I have a DMM, here I have a variable power supply. Do you see I stop a variable power supply here? So this is a digital multimeter. So here I stop. Do you see here I choose a voltage? So these two modules have been highlighted so that where we connect our probes. For example, when I say I want to measure a current, do you see over there these two terminals are highlighted? So when you can define how exactly to teach your multimeter concepts also, you can teach with this. This is for the continuity. This is for your diode check. So your AC volt or DC volt layer, and you have an automatic range, or you can go for a measurement range levels there. So you can easily measure it in which levels you need to have, or you can define your automatic levels. So for variable power supply, we have a positive, we have a negative range. So where you can define with this, for example, when you want to plan something as a IV analyzer, for a diode characteristics, if you want to plan for it, you will be generating a sweep of power supply voltages where you generate with this. So this, if you see there, this module will internally generate a sweep. So where you will be connecting to the respective terminals to it. So here we have in our module as an IV analyzer here. So DUT, device under test. So here in IV analyzer, you can use your diode, or you can use your transistor for the HRV analysis. What would be the base current? What would be the emitter current? To calculate their PNP or NPN saturation points. So you can use easily your base DUT plus and minus. You will be connecting respectively to the collector and emitter terminals based on the transistor models. And we don't want to worry about, because this will tell you about how exactly we will be using our uh, for example, if you see, I can show you there in IV analyzer. So here they'll show you in this how you can connect with this. So where you can set your start volt, stop voltage over there, and you can define easily there. So if you see over there, this is something as a normal LED what they connected and use it. So you can replace this device. So actually this is a DUT place where you can test your different devices there. So the units can be anything. It can be an LED, it can be a diode, it can be your MOSFET, or you can use your BJTs, or it can be of any different devices you can try with this. For example, if you want to measure inductance also, you will be connecting with these levels in the previous modules. So now you have a dedicated multimeter lines to do with that. So you can easily test your resistors, or you can easily test your inductors, and you can easily use with this for this IV analyzer there. So this would one will be really helpful in planning your lab sessions. So what experiments we can go with function generator and oscilloscope combinations, in what uh, experiments we can go with the power supply and multimeter combinations. So where we need to go with the analog input lines and analog output lines to generate there, and where we need to have a fixed power supplies for our logic gates. So where we need to use our IV analyzers for the IV characteristics of the units there, where we'll be using the pattern generator or logic analyzers modules for our experiments. So everything we can plan with a single hardware, and this can be taken in person with a lab, and also we can work, and also we can use it in a remote operations also, provided if we have a pre built connections over there, if the connections are already available on the board there. So only simple you can turn on, and you can vary your function generator values, and you can see your rest of your oscilloscope modules, and you can easily do it. So afternoon we'll see a demonstration of this module. So how exactly you can connect sensor, where you can vary your function generator, how it is affecting in your oscilloscope, how we can have a small circuits connected with it. So we'll be seeing that in the afternoon sessions. So any queries so far? Almost most of the points related to the NI Elvis module I have covered. So here probably I can show you further how you can go with. So these are the devices what you can have it. So now if you see there where I don't have any device connected now, that's why I have a simulator device. So when you have your device connected, so you'll be connecting with an Ethernet or a USB, where you'll have your IP address connected there. And these are the additional items you will get. So now we have only 4 items: oscilloscope and function generator, multimeter and variable power supply. Once your module connected, you will be getting with body analyzer and current voltage analyzer, and you'll be having a logic as well as pattern generator there. So if you see there, these instruments, they are shared internally. So whenever you use a function generator, you may not use logic analyzer or body analyzer there, because if you see there is body analyzer where you need to have a stimulus channel as well as a response channel. In that point, it will be using one of the function generator and oscilloscope channels there. So one channel will be your stimulus signal generation channel, and the other one will be checking your responsive oscilloscope channels they'll use. That's why they said instruments that use same resources cannot be run simultaneously. You may not use body analyzer as well as function generator oscilloscope there. So that's why you see there that question mark is there. If the device is in use, you cannot use with the other one. That's what it says there. So here, these one what we have seen, and these things are soft front panels. So it tells you what are these applications are there. And one good part what you have here is, if you all connected with your multi-user, here it will tell you about how many users you can share with it. So if the devices are shared, so now if it is used with only a single user, you can share this hardware with the different resources also, so that what you can have it is multiple people can work with this hardware. Do you see there? Different peoples are accessing this hardware. So different peoples are working with these modules there. So for example, if you see there, one hardware you can connect it with the different students, and at a time you can allow one student to conduct an experiment, and the other could see it. When the next student is performing some experiments, other students in a group, you can ask them to note it down or take values. The same thing how you are doing in your regular lab. 2 members in a group or 3 members in a group, you assign one hardware and you use with this and you work with it. The same way also you can go ahead. Do you see there, these modules I told you, right? Once the hardware is connected, you'll get the information about the hardware, and also you will also get the information about whether it is being shared with a single user or multiple users in a group. So this hardware can be shared in a group and you can work with. These are all small advantages as this module has as an application wise. So this is the body analyzer part where you are looking at the stimulus channel and the response channel. Since we are accessing only one response channel, we are getting only one element in it. So when you have multiple circuits, probably you can plan for multiple response channels for it. So these modules you can explore with your Simulink also. So these modules will have Simulink support. MathWorks also will support for this there. So where NA drivers also support you to work with different programming environments. And this module not only used for basic circuit designs. As I told you, it is something as a one body, or I can say something as a one brain, where you can fit into different bodies there. That's the reason if you see that the baseboard is common. I'll show you there. NI, Elvis, 2+ top boards. So what you will be doing is we'll have a different plug-in top boards on top of it. So where if you see there only one device will be there, where we can add multiple devices connected to it. So you see there, I'll show you different top boards available with this. You can remove this top board and you can insert a new device. So now I have a basic programming board. If you see that I have only a basic programming board there. So if I remove this breadboard, if I connect this motor board. So this is something as a positioning and speed control of a DC motor. So where we can learn modeling, where we can have a controls. So everything we can do with this DC motor there. This is one. So the same module, so we have it in a different way, something as for this inverted pendulum. So do you see that this is for the inverted pendulum for units? So here these modules will help you over to learn different parameters, modeling factors of an inverted pendulum there, where you can learn different control system related stuffs. So this is what one is for your motor speed and other things you can use, and the other for your inverted pendulum options there, which it comes with an encoder is also connected to it, where you can easily modeling them. And this one is for the VTOL, vertical takeoff and landing. So this is for the aerodynamics, so lab which you can use with it. And this something where you can use for your I could say it as a different lab modules you have. So one for your optical communication labs you can have, one for your signal communication labs you can have, and one for your HVAC labs you can use with this. For different thermodynamics you need to learn with this. So many parameters you can define in it and you can learn. So these are all different parts which I could see there. If you see that there are lots of add-on boards we have, so which helps for peculiar lab activities which we can do with it. I could say it as uh, NILS transfer top boards. So do you see the different top boards we have for different applications? So these are the different top boards. For biomedical also we have an application over there. So we could say it as an NILS biomedical engineering. So if you see in it, so with this we have a different biosensors we have. So do you see in it, this is a myoelectric add-on board. So where you have the electrodes connected with this, so where we will be reading these values with the ECG or EMG values, we can easily take with this as this way, usually connecting, and you can be using it. And we have different biomedical sensors also where you can connect with this and you can work. This is an EKG sensor, and one will be with your biomedical sensor kits you can have. So several elements you can connect and you can use with your devices there. It's any simple DAC card also you can work. Either you can use it as a normal DAC devices, or we can use it as a biomedical related application, or we can use it for a controlled system lab, or we can use it for a previous one. I can show it as different labs of thermodynamics or actuators controls, or aerospace modules if you want to learn vertical takeoff and landing. So what would be the thrust involved in it, so how these modules will behave for it. If you see there, simply we will be including this add-on board to the Elvis hardware. So this is something as a one module where you have different parts, so where you can have in it. So the base board remains same, only these add-on boards will change for the different labs and equipments there. So instead of this blue colored top board breadboard, so we'll be using for it. So this breadboard what we have is for I could say it as a basic circuits lab we can have, or for a LAC lab we can use for it, or digital electronics lab or digital circuits lab where we can plan for it for initial logic gates design or an amplifier design or integrated designs, you can easily do with this with the help of function generator, oscilloscope. You can easily go with this. To go on a higher semester labs, so probably what we can do it is we'll try to put a small add-ons to it so that we'll be concentrating on that particular uh, concept and application related experiments we'll be using with this. Could you see over there? Here I have one stepper, I have one servo there. So these are the different elements where we have, and these are the add-on boards from Quanser. So if you see over there for Quanser top boards for NA Elvis also we have. So whatever I show over there, it is all available in this Elvis add-on boards here. So you have different. Even in this also, Quanser also we have a lot of materials related with this. So where we can go on different coursewares for it or manuals for it. So where how we can conduct these experiments, how we can move on with these options, we can easily go with it. So for example, if I say a mechatronics add-on board, so this will tell you what are the different labs that you can do with this. You have a LabVIEW course where you have. So very nice details we have in this. For example, if you go with this courseware, you can easily download with this. I'll just open this so that how exactly you can customize them, and what are the different elements that you can do with this. For example, if you see you have a DC motor, you have a brush to DC motor and brushless DC motor, both we have, and this courseware has informations and programs uh, put together in this, so that you have this entire programs which will be comes with the two different format. One is for an instructor for the faculties, and other for a student workbook, so that you can assign tasks or assignments, or you can teach why you want to vary this angle parameters for this stepper or a servo, or if you want to have this controls for it, or you want to have some modeling devices, how you can do with this. So those parameters you can easily teach students in a easy way there. So, and moreover, the same way, if we come for moreover, if we come for this Quanser controls board, so here you have a really good of control systems modeling panels you can easily use with. So now do you see that these labs you can conduct with the help of Simulink as well as LabVIEW. So you have both the coursewares available there. So this will really help you based on the faculty expertise in the lab softwares, what they use with it. Based on that, you can prefer in what way you will be using in it. So hardware does not have any limitations. Based on the faculty expertise, they can choose which programming software they go with it, and you can easily get to it. The labs there. So now probably we can go to queries part, so that we have another 20 minutes where we can start. Do you have any queries? Which lab we will be working with this or using this? How it would be helpful? Any queries? Probably we can discuss with that. Okay. Is there any queries you have?
Participants, if you have any queries, so you can ask us.
Or else probably I'll show a quick demo of this modules, how you can do program and to use with this. Afternoon we'll see about with lab experiments, how they can easily go with that. So for example, if you see there, I'll go to lab view there. So I have a lab view for NA Elvis, or I'll start with the lab view. So I'll go with the lab view there. So in LabVIEW platform, I am programming for NA Elvis 3 hardware. So I'll choose an NA Elvis 3 project. Yeah. So now if you see over there, so I have this module, whether it's connected with USB or whether it is connected via Ethernet or Wi-Fi, or which module I want to use with. So I want to use with this Elvis 3 there. So I'll say finish. So now it identifies my module and it shows me these are the terminals available for this. So how you are going to program for it. So that I'll be doing it in LabVIEW there. So these are the IOs I have. So now it is adding the real-time hardware and RT FPGA hardware to my LabVIEW part. So where I'll be start doing my program. Yeah. So now if you see, I have this project. So first let me save this project. So now do you see over there, I have one project. Under my project, I have my computer, my laptop with me, as well as I have a Elvis computer. I said Elvis 3 is a separate computer where we can work without a PC also it can work. See, now the hardware does not have any IP address. So now if I want to connect this hardware with some IP address in a network, so what I'll do is I'll give some IP address there. For example, 192.168.10.2. So I give it that. So what happens is the hardware will have the IP address assigned with this. So in a network, I can easily use. So now I go for it. So I can add a VI to it. Right click, new VI. So when we add a VI to it, do you see there a new program is coming under Elvis? This program is nowhere running in my computer. My computer is used to only configure the programming part for Elvis. The rest of the things will be happening in the Elvis itself. So I'll go to the front panel and block diagram. So here, if you see over there, yesterday you would have seen about how front panels will be used, how block diagrams will be used for it. For example, if you see there, I'll go to my block diagram. So here I'll go for academic IO. So where I have these hardwares available with me. And do you see there this body analyzer or IV analyzer or DMM function generator? These devices also I can program them individually. As I mentioned, I can program these devices individually. I can configure them and I can acquire values through it, or I can acquire through this analog input, analog output. I can use this protocol based sensors configurations. I can work. If you see that I want to acquire data through an analog input module, so I'll say an analog input there. So through which line or which channel you need to acquire your data. So I need to acquire one sample or n sample or continuous sample. I want to acquire continuous samples. So now it is showing me what are the channels I have. So I have these analog input channels of A bank. I have analog input channels of B bank. And also I have for differential configurations also I can use with this, because single ended continuous, differential ended continuous. That's the range what it says there. So I'll say analog input A channel 0 and sampling rate I can say it is of a 10 kilohertz sampling rate. So sampling rate at 10 kilohertz. So 1K samples I can acquire. So I'll say validate. So I'll say OK to it. So now if I want to see the code, do you see that generating a code? So I am not performing any program for it. LabVIEW itself will develop a program for the hardware there. Do you see in it this hardware code, whatever I required for it, it's already taken and it included in it. I'll say OK with this. So I only define through which channel you need to acquire the signal. I say OK with it. So I save all the changes what I made with this code. So now LabVIEW will build a program for me and it will keep for me. So I'll go to block diagram. So do you see that it continuously acquire data there? So this continuous acquisition I'll see through a graph. Sorry. I'll take waveform graph. I connect the signal output to the graph. Since it is a continuous one, so I want to include everything into a loop. I create a controller, the first start button. So now what I'll do it is when I run, so what will happen is this entire code will be try to deploy into the NILVS hardware. So this is how the deployment process will start in it. So it is checking for the items. So it will say waiting for the target to respond. I don't have hardware, so it could not respond. So afternoon we'll see that how you will be programming with this. Okay, fine. So the similar way you will be programming for your oscilloscope channels. So when I say for oscilloscope, when I say initialize it, when I go for configuration analog channel. So when I say analog channel here, I'll be defining which channel I'll be using it. So channel information. So I'll create a control for it. Do you see there through which channel scope 1, scope 2, scope 3. So which channel will be using it. So after acquiring data through it, so then I'll be oscilloscope, read data. So this reference will be connected. So after this, the same waveform graph, I'll have a copy of it. And the signal, whatever I have taken analog waveforms, that I'll connect to this waveform. So as per this particular, I'll be taking, so here what is the ranges, what is attenuations, so I can define them. So here, for example, I want to enable this channel or what, or I have another option called as auto config. So here I have an automatic setup. So where I have to define which channel I need to give. So based on the hardware, what it takes input, which will be adjusting it automatically and gives the waveform for it. So I don't want to define the ranges of voltages. I don't want to define the offset for it. I don't want to define the coupling parts or probes values. So I don't define anything. This is something as manually you configuring every individual parameter of an oscilloscope. Here is something as you are defining a device to take automatically, let it take and work. So that's what it is. So as every individual small program also you can do for your instruments of NA Elvis 3 hardware. So any hardware associated with this NA Elvis hardware you can easily use. Okay. Any queries? It's another last 10 minutes. So no queries? Has anyone of you worked with LabVIEW earlier with any of the hardwares? Hello, sir.
Hello, sir.
Is there any queries from your end or from the participants' end?
I think no, sir. So that's why I think they are not replying.
I think from morning they're in the session, right? They would have got exhausted.
Yeah, yes, sir. So after lunch we can continue, no, sir.
Yeah, after lunch we can continue on issues.
Yes, thank you, dear participants. And now we'll be having the lunch break. So after that, exactly by 2 o'clock, again, Manimaran sir will start with the presentation. So everyone join back at exactly 2 o'clock. Thank you, everyone. Thank you, sir. Thank you very much for the excellent
Thank you, sir.
presentation.
Thanks.
Yes.